Good evening, good morning, good afternoon, depending on your respective time zones. This is Statistical and Geospatial Insights YouTube. We are meeting again in lesson number 21, which is Introduction to Standard Normal Distribution. By the end of this lesson, you'll be able to describe the importance of a standard normal distribution in statistics. You'll be able to describe a standard normal distribution main features. You'll be able to use the standard normal distribution table for probability calculation. First of all, let us look at some of the symbols used to denote the population parameters and the sample statistic. The Greek letter mu is used to denote the mean for the population, whereas X bar is used to denote the mean for the sample for your sample. The standard deviation for the population is denoted by the Greek letter sigma, whereas the sample standard deviation is denoted by S. The population variance is denoted by sigma square, whereas the sample variance is denoted by S square. What is a standard normal distribution? The standard normal distribution is known as the Z distribution. This is a distribution where the mean is 0 and the standard deviation is 1. Any normal distribution can be standardized by converting its values into z-scores. Z-scores tell you how many standard deviations from the mean each value lies. What is the importance of a standard normal distribution? First of all, the standard normal distribution is regarded as a universal ruler that can be used to compare different normal data. It is also used to find the probabilities, that is the area under the curve. It is also used for statistical inferences, such as testing hypotheses. It is used to simplify complex calculation by using the Z tables or software to determine the likelihoods. Key characteristics. When you look at this curve, first of all, let us look at the center of the distribution. The center of the distribution is the mean, the median, and the mode. They are all equal and located at the center. However, in the case of the standard normal distribution, the mean is 0 and the spread, which is the standard deviation, is 1, 2, or 3. Standardization is one of the functions of the standard normal distribution, which means that any normal distribution can be converted to the standard normal distribution by calculating its z-scores using the formula z equals x minus mu over the standard deviation, which is sigma. So the x is the raw score, the mu is the mean, and the sigma is the standard deviation. Characteristics. First of all, the probability. And you remember when we started talking about the normal distribution, we say the area under the curve for the normal distribution, usually this area is the probability, it is 1, which is 100%. However, when you look at this area here under the curve, you'll find that 68% of the distribution is within the limit of 1 standard deviation, 95% within the limit of 2 standard deviation, and 99.7 is within the limit of 3 standard deviation. So the standard normal table is a very important table that we use to find the cumulative probabilities for the z-score, which represent the number of standard deviation value from the mean in a standard normal distribution. This table is commonly used in statistics for hypothesis testing, confidence intervals, and probability calculations. First of all, let us see how do we read the table. So this is the table. So you have the probability from 0 up to 0.09. This is the probability. Then the column here, you have the z-score. You have the z-score from minus score to 0 scores to positive scores. The minus scores means that uh, the unit is below the mean, which is 0. So anything below 0 is minus, and then those one which are positive means that they're above the mean. They're above 0, which is the mean for the normal distribution, for the standard normal distribution. Now, how do we read the table? Usually, you look at the probability. You see the column for the probability when it intersects with the row. This is the row. For example, if this one intersects with this here, so this is your probability in this case. So we're going to have a practical example to make it very clear. Now, the example is asking you to calculate the probability of a z-score of 0.32 for a student's test score. This means that the score is 0.32 standard deviations above the mean. Solution. We go to the table. First of all, 0.32 is equal to 0.3 plus 0.02. So this is your probability. The 0 here 0.02 is the probability. So we go to the table. You look at the column for the 0.02, and then you come down and look at the z score, which is 0.3. The intersection here gives you the probability, which is 0.62552. Therefore, here, the probability is 0.6255, which is 62.55%. What does it mean? It means that 62.55% of the values in a standard normal distribution are less than 0.32 standard deviation above the mean. Thank you for follow up, and please you subscribe to the YouTube so that you'll be able to to download the other YouTube which are coming after this.